Welcome to the deep dive. Today, we're going to be taking a look at how C++ handles, talking to the outside world, all that input and output stuff that makes our programs actually, do something.
Right.
Our source today is going to be a section from cppreference.com. Think of it as the ultimate C++ cheat sheet. It's used by basically everyone who codes in C++ Cree. So whether you're like a coding ninja or you're just starting out, this deep dive will hopefully give you some cool insights into how C++ manages data coming in and going out.
It's a fundamental part of programming. You can't really do much without being able to, read information and then display the results.
Exactly. So how does C++ handle this whole input-output thing? I see the word stream popping up everywhere in the material. What's that all about?
So imagine like a pipeline carrying data. That's essentially what a stream is in C++ Dig. It treats data as a continuous flow, whether it's coming from a keyboard, a file, or, going to your screen.
Okay, I'm picturing it. But C++ is an object-oriented language, right? So how do streams fit into that whole world of classes and objects?
Yeah, good question. So C++ has this clever hierarchy of stream classes, each with its own specific role. So at the base, you have this class called iospace. And it's kind of sets the ground rules for things like formatting the data, handling errors. Then you've got base-eos, and this acts like the manager in a way, keeping track of where the data is coming from and where it's going.
So it's like base-eos knows if we're reading from a file.
Or
if we're taking input from the user.
Precisely. And then you have basic stream buff, which is really where the rubber meets the road. It handles all the really nitty-gritty details of actually interacting with that physical device, whether it's a hard drive, a network connection, or whatever.
So it's like a specialized translator that can speak the language of each device.
Yeah, you got it. And then built on top of that foundation, you have specific stream types for input, output, and those that can do both.
Okay, yeah, that makes sense. So you wouldn't use the same tool to read data from a file as you would to display text on the screen. So let's talk about file I/O. It seems like C++ makes working with files pretty straightforward.
It really does. You have classes like BasicStream for reading from files, BasicOffStream for writing to files, and BasicStream if you need to do both.
And I see this other class here, Basic File Buff. What's its role?
Think of Basic File Buff as the middleman between your program and the actual file on disk. It takes care of all those low-level details of storing and retrieving the data.
So it's like the efficient librarian who knows exactly where everything is stored in the giant library of our hard drive.
That's a great way to put it. Now, files are great for storing data permanently, but what about when you need to work with text within your program itself? That's where string streams come in.
Yeah, string streams. They let us treat text as if it were coming from a file or going to a file, even if it's all happening just within the program's memory.
Right. They're incredibly useful for things like, parsing text, formatting output, or even doing some light text processing. And you have this whole family of stream classes to handle all those scenarios.
It's like having those mini input and output pipes within the program itself, almost like a miniature version of the file I/O system. And speaking of specialized I/O, I see something here about array I/O. Is this something new?
It is relatively new, yeah. C++ 23 introduced this feature to handle working with those fixed-sized chunks of data you often find in arrays.
Okay. But why do we need special tools for arrays? Can't we just treat them like any other data?
Well, you could, but array I/O, especially when using this cool thing called a span, can make things way more efficient. A span basically gives you a lightweight view of the array's data without having to copy it around.
So instead of making a whole new copy of the data every time we want to process it, we can just use a span to point directly at the original array.
Exactly. This is especially beneficial when you're dealing with large amounts of data, like you might find in, image processing or scientific simulations. It saves memory, and it can significantly speed up your code.
That's pretty awesome. It seems like C++ 23 is all about making things faster and leaner.
Definitely. And speaking of performance, another cool addition in C++ 23 are the print functions. They're designed to format and output text incredibly efficiently. And they often outperform the traditional stream approach for those basic output tasks.
So these print functions are like the streamlined express lane for text output.
Exactly. They bypass some of the overhead associated with traditional streams, making them a great choice when speed is critical. And they're locale independent by default, meaning your output will look right no matter where in the world your code is running.
That's impressive. It sounds like C++ 23 brought some significant upgrades to the I/O toolkit. But with all this fancy new stuff, I'm curious. Does C++ still support those good old C-style I/O functions, like print and its buddies?
It does. Even though C++ has its own powerful I/O library, it retains compatibility with those classic C functions.
So why would a C++ programmer choose to use those older C-style functions when they have all these cool new C++ tools at their disposal? Is it just like a matter of preference? Or are there specific situations where those C functions might still be the better choice?
There are a few reasons. Sometimes it comes down to familiarity. If a programmer has been working with C for years, they might just be more comfortable sticking with what they know, or maybe they're working on a project. That needs to maintain compatibility with existing C code. And in some very specific niche scenarios, those C functions might still offer a slight performance edge.
So it's like having a trusty old toolbox. Alongside your shiny new toolkit, sometimes you just need that familiar hammer or screwdriver for a quick fix.
Precisely. C++ gives you options, recognizing that different situations might call for different approaches.
Okay, so we've covered a lot of ground here. From the foundational concepts of streams and buffers to the specialized tools for files, strings, and arrays. It's clear that C++ has this, rich set of features for handling all sorts of input and output scenarios. But before we move on to exploring some real-world applications of these features, I'm curious.
What stands out to you so far? What maybe sparked your interest? Or maybe raised a question in your mind?
Honestly, the whole concept of streams is really clicking to me now. It's like C++ has created this elegant way to abstract away all the complexity of dealing with different data sources and destinations.
It's one of those concepts that, seems simple on the surface, but it has profound implications for how we design and write programs.
Totally. Okay, so we've talked a lot about the technical, nuts and bolts of C++ I/O.
Yeah.
But I'm always curious about the practical side of things. How do these features actually translate into real-world applications?
That's where the real fun begins. Let's say you're building a simple text editor, the kind of program where users can write and save their brilliant ideas.
Yeah, a classic example. So where does C++ I/O come into play?
Well, right off the bat, you'd be using file I/O to handle that core functionality of opening, saving, and reading text files. Imagine a user typing away, crafting their masterpiece. When they hit save, your program would spring into action using basic offstream to neatly write that text to a file.
So basic offstream is like the digital ink that flows from the user's keyboard to the file on their hard drive.
Precisely. And when they want to reopen that file later, maybe to edit or admire their work, basic offstream takes center stage, diligently reading the contents of the file and displaying it back in the editor window.
It's amazing how these classes work behind the scenes. To make something as seemingly simple as opening and saving files seem effortless to the user.
It's a testament to the power of abstraction. And file I/O isn't just limited to text editors. Think about any program that needs to store information for later use. Spreadsheets, databases, games, they all rely on this fundamental mechanism to manage their data.
So file I/O is like the persistent memory of the digital world. It allows our creations to live on. Beyond those fleeting moments of program execution, that's pretty profound when you think about it. Okay, so we've got file I/O covered. But what about those string streams we talked about earlier? Where do they fit into this picture?
String streams are indispensable when you need to manipulate text. Within your program itself, let's say you're building a program that analyzes user input, maybe to extract keywords, or figure out the sentiment of a sentence.
Okay, I see where you're going with this. So instead of treating the user's input as just this big blob of text, we could use basis string stream to process it like a stream, like word by word.
Exactly. It gives you that fine-grained control over the text, making it much easier to perform those kinds of analysis. And on the flip side, you might use basic string stream to assemble the result of your analysis into a nicely formatted string that you can then display or log.
So string streams give us this elegant way to bridge the gap between that raw text data and the structured world of our program.
Couldn't have said it better. They're like those versatile Swiss Army knives in a programmer's toolkit, always ready for a variety of text manipulation tasks. Now, you mentioned earlier being intrigued by array I/O and span. Let's dive into that a bit more.
Yes, I'm still wrapping my head around when I might actually need to use array I/O.
It really shines when you're working with fixed-size buffers of data, especially when performance is critical. Imagine you're building an image processing application. You're dealing with massive arrays representing pixel data.
Okay, I can see how efficiency would be paramount in that scenario. You don't want the user waiting forever for their filters to apply.
Precisely. Now, in the past, you might have had to create copies of those arrays just to process them. But with array IO and span, you can often avoid that copying altogether.
So span lets us work directly with the original arrays data without making a duplicate.
That's the idea. It's like having a window into the data, allowing you to access and manipulate it. Without the overhead of creating a separate copy, this can be a huge performance win, especially when you're dealing with large amounts of data.
I'm starting to see the appeal. It's like optimizing at the data level, minimizing those unnecessary data shuffles. And this all came about in C++23.
It did. C++23 brought some powerful new tools to the table. And array IO with span is a prime example. It reflects the, evolving needs of developers who are tackling increasingly data-intensive tasks.
It makes you wonder what kind of cool I/O features they'll come up with next. Speaking of cool features, we touched on synchronized output streams earlier. Those sound crucial for multi-threaded applications. Can you give me a real-world example of where I might encounter those?
Absolutely. Imagine you're building a complex simulation, like a weather model or a financial market simulator. You might have multiple threads running concurrently, each generating output that needs to be displayed or logged.
Okay, so it's like each thread is producing its own little stream of data, and we need to make sure they all flow together smoothly without creating like a jumbled mess.
That's a great analogy. Without synchronized output streams, you could end up with output from different threads, interleaved in unpredictable ways, making it difficult to interpret the results.
So synchronized output streams are like those skilled orchestra conductors, ensuring that each instrument plays its part at the right time to create a harmonious symphony of output.
Exactly. They bring order to the chaos of multi-threaded output, ensuring that data from different threads is written in a coherent and predictable manner.
It's incredible how C++ provides these like specialized tools for scenarios that most people probably wouldn't even think about.
It speaks to the depth and thoughtfulness of the language's design. It's not just about providing the basic building blocks. It's about anticipating the challenges that developers face and offering, elegant solutions.
Well said.
Yeah.
We've covered a lot of ground here, from those foundational concepts of streams and buffers to these powerful features like array IO and synchronized output streams. It's clear that C++ has this rich and evolving IO toolkit. But before we wrap up this exploration, I want to touch on something that's been on my mind. With all this talk about performance and efficiency, I'm wondering, is there ever a time when using the C++ IO library might actually be too much? Like, are there situations where it might be better to go with something simpler, even if it means sacrificing a bit of speed or flexibility?
Yeah, that's a great question. And you're right, there are definitely times when the full power of the C++ IO library might be overkill. For example, if you're working on like a really small embedded system with very limited resources, you might choose to use more bare-bones I/O mechanisms just to conserve memory and processing power.
So it's like choosing the right tool for the job. Sometimes you need a precision scalpel, and sometimes a sturdy hammer will do just fine.
Exactly. It's all about understanding the trade-offs and making informed decisions based on the specific needs of your project. And this brings up another important consideration: code readability and maintainability.
Right. We can't just focus on making our code run fast. It also needs to be understandable by other programmers, including our future selves.
Absolutely. Sometimes using a simpler I/O approach, even if it's slightly less efficient, can make your code much easier to read and understand, especially for someone who might not be a C++ I/O expert.
It's like choosing clarity over cleverness. Sometimes it's better to write code that's straightforward and easy to follow, even if it means sacrificing a few microseconds of performance.
Precisely. And in the long run, that can save a lot of time and headaches when it comes to debugging or making changes to your code.
So it sounds like mastering C++ I/O isn't just about knowing all the classes and functions. It's also about developing a sense of when to use them and when to maybe opt for a simpler approach.
Couldn't have said it better. It's about finding that balance between power and practicality, efficiency and elegance.
Well said. And speaking of balance, I'm curious. As C++ continues to evolve, what do you see as the future of I/O in this language? Are there any exciting new developments or trends on the horizon?
Oh, I think we'll continue to see a focus on making I/O even more performant and scalable, especially as we deal with these increasingly massive data sets. Imagine C++ I/O libraries that can seamlessly handle terabytes or even petabytes of data distributed across clusters of computers.
That's mind-boggling. It's like the I/O equivalent of those massive particle accelerators, handling huge amounts of data at incredible speeds.
Exactly. And I also think we'll see tighter integration with other emerging technologies like cloud computing and machine learning. Imagine C++ programs effortlessly streaming data to and from cloud storage services, or interacting with AI models in real time.
It's exciting to think about how C++io will play a role in shaping these cutting-edge fields. It seems like we've only just scratched the surface of what's possible.
Definitely. And that's what makes it such a fascinating area to explore. As programmers, we're fortunate to have such a powerful and versatile language at our disposal.
Well said. And to all of you listening, we hope this deep dive has given you a newfound appreciation for the intricacies of C++ input-output. It's more than just reading and writing data. It's about connecting our programs to the world, enabling them to interact, adapt, and evolve.
We've journeyed from the foundational concepts of streams and buffers to those cutting-edge features that are pushing the boundaries of what's possible with data.
And along the way, we've seen how C++io empowers us to create everything from simple text editors to complex simulations, and even pave the way for the data-driven applications of the future.
So keep exploring, keep experimenting, and keep pushing the limits of what you can create with this remarkable language.
Thanks for joining us on The Deep Dive.